Hi guys. Hi. Yes, you meet me here again. I'm Gabriel Bagit and Alex from the E2. And today I'm gonna do a short video review about how a microchip makes. Alright. First of all, as you can see here in my screen that I'm sharing, uh, this video names title are how a microchip made, and it was posted by interesting engineering, and they got about 1.23 million subscribers from around the world. And these videos was posted on January 4th, 2022. And there's a few of descriptions inside here. There's right because of brains we have most everything we use in your using electronic world, and here's how to generate. And they put the link here if we want to find more information about how the microchip made, and to get the latest science technology news to our newsletter. Oh yes, and they have a newsletter. It's about e-news, which is called the Blueprint, and all of you can press this. And as you can see, this video has not been reviewed, but been viewed by people around the world for about 5,751,093 views have been watched, and viewers have been watched these videos. And here we can see the comments here. Yes, it's quite positive here. You can see this surely the greatest on list most intuitive feat of engineering the humanity is produced, and sometimes we clarify how we can progress so vigorously from 90 to thousands. Any of our modern technology is easily seen as like magic back in the days. Yes, and so on. Right, we go to our focus, to our main topics for today, which is I'm gonna do a review about this video. As you can see, inside the screen, and I share. It's about how a microchip made. So as we start with the introductions to the videos, and we watch along with me, and we're gonna do a little bit review on the videos. Okay, let's we start it. Boom. Oh, wait.
This microchip can take up to 26 weeks to make, in its as many as 100
I'm
layers.
gonna
Billions.
we will start it again. I'm gonna use a playback speed around 0.75 to make it a little bit longer,
This microchip
and
can take up to 26 weeks.
to make it a little bit easier for us to watch the video so that it will not be too fast, right? And I will start it again as we watch it.
This microchip can take up to 26 weeks to make, in its as many as 100 layers. Billions of transistors are packed into an area about the size of a fingernail. They're the brains behind almost everything we use in our increasingly electronic world. Here's how these complex, tiny devices are made.
All right, just now, in introductions, they said that the microchips takes 26 weeks to make, which is quite quite long for it to for the factory for the manufacturing company to produce it or to make it. All right, and inside the microchips here, which is inside microchips, which it is contains billions of transistors inside it, which is just a small like this fingernail or my fingertips. It's like this only, right? Just like this. It's only big. It's only the size of this. Don't know me 1 mm or 1 centimeter to 1 centimeter, one time 1 centimeter. Maybe that's maybe that is the size. I don't know. And Yes, about 7 finger, or maybe it's 1 to 1.5 centimeter, like that. And it also has state that the microchips are the main things that we use almost in everything electronics that we use, which, such as example like this, the smartphones, I think it have contained a lot of microchips. Not a lot, but it contain microchips. I don't know whether it's so many or not. Um, uh, Inside the tablet, inside the laptop, inside the computer, inside the PC, inside the monitor of the PCs, and many more, many more electric and electronics things. They use the microchips. So we continue watch the video.
Use in our increasingly electronic world. Here's how these complex, tiny devices are made. The process begins with silicon rich sand. Why silicon? Silicon is a semiconductor. It's the sweet spot between an insulator and a pure conductor. That means its properties, such as its conductivity, can be altered by adding impurities or doping to meet the needs of different electronic devices. This also allows us to control the electrical signals that pass through. Silicon is also abundant. It's one of the 10 most common elements found on Earth. But much of the silicon found in the wild is chemically bound to oxygen, so the two elements must be separated. The sand is combined with carbon and melted in crucibles to produce carbon monoxide and 99% pure silicon. After further processing, ultra pure silicon is produced. Next, a seed crystal is placed in contact with molten silicon. As the seed crystal is slowly pulled away, silicon atoms are deposited on the bottom surface. The result is a large cylindrical boule, or a single crystal ingot of pure silicon. The boule is then thinly sliced into wafers. Silicon wafers typically have diameters of 1 to 12 inches, with the most state of the art facilities being able to produce wafers up to 18 inches in diameter. Bigger wafers are, of course, able to yield more microchips.
Yes.
Once the silicon wafers are cut, the production process begins in full. Microchips are made in extremely sterile conditions, free from contaminants such as dust. If even just one particle of dust makes its way onto a silicon wafer, the entire batch is at risk of being ruined. This would derail a process that can take an average of
As you
12
can see, there is
weeks. The
like a
first
round
step
one,
of
right?
the production
Inside the round one,
process
there's a
is
lot of microchip,
deposition.
a lot of
A
microchips
thin,
here.
non conducting layer of silicon
Silicon oxide
dioxide
there.
is grown or deposited
You
on
can
the
see it there.
surface of the wafer. Then
Yes.
the silicon wafer is prepared for lithography by coating
Lithography.
it with photosensitive and light resistant materials. The next step is very critical: exposure. The prepared silicon wafers enter a lithography machine and are exposed to UV light passed
Here
through
you
a
can see inside the
reticle
round plate
containing the
of
chip's
the silicon.
blueprint. The
As you can see, after the what? So they heating the sand to produce the silicon, and the silicon then compressed into the about round things like a plate, right? After that, in the round plate you can see inside the video just now, is what with as you can see here, it's like a square shape, right? Like big size, like my fingernails, my fingertips. It's like this. Right inside that. inside that, not inside that, but in the small plate like this, in around 18 inch. Inside that, a small square like fingernails like this, that are the microchips, right? That are microchips, and you can see here, it's now they say they are supposed to UV light passes, right? Like on
pass through a reticle
through a
containing the
green,
chip's blueprint.
yes, to make the chip.
The areas exposed to light are hardened, while unexposed areas are then etched away by hot gases to leave a three-dimensional microchip.
As you can see, here is the microchip that have been molded, have been passing through lithography, passing through the heating process, and now they're ready to put the microchip to the next stage, right? To make the microchip, to bring the microchip to the next stage of the production steps. Right now, we continue to watch the video.
The electrical conductivity of
Yeah,
different
here is the microchips. You can see in the screen. Sorry, here. This is the microchips. This is the motherboard, and this is the microchips.
parts of the chip can also be altered by activity of different parts of the chip can
Microchips
also
will
be
be
altered
altered,
by
doping
doping them
them
with
with chemicals.
chemicals
Yes,
under
yes.
heat and pressure. This process can be
Yes, this
repeated
one is the
hundreds of
glass.
times for the same
That
chip,
is the microchips,
producing a
okay?
more complex integrated circuit at each
Stage.
step. To create conducting
Conducting
paths
paths
between the
between
components,
components.
a thin
Thin
layer
layer
of
of
metal,
metal.
such as aluminum, is
Aluminum.
overlaid onto the chip, and the
Yes.
etching
Now we
process
go to the
is
etching
used to
process.
remove everything except the thin conducting
Conducting
pathways.
pathways.
Several layers of conductors separated by
As you can see, just now, wait.
pathways. Several
Stop. In the round plate, we have small pieces that have been cut into a square or rectangle. Inside the rectangle things, you can see,
layers of conductors
yes, that several layers of conductors that connect that can use to connect any other electronic things, right?
separated by glass
Glass
insulators can be
insulators laid
laid down.
down.
Each chip on the wafer is then tested for
Yes, then it will be tested for performance. And the function of this is to make sure that the microchip are not problems, and is ready to use, and is ready to sell, is ready to distribute to the users, or the company to use for making the electronics devices, right?
performance before it's
It's separate
separated
from other
from other
chips.
chips on the
Yeah.
wafer by a saw.
So
Since microchips are essentially
circuits
circuits built
built
on an
incredibly
incredibly
small
small scale,
scale.
they have a basic set of components. Capacitors can temporarily store an electrical charge. Resistors
Can
help
control the
control the
electricity
electrical
current,
current. Transistors can either amplify
amplify.
or switch the electrical signals passing through. For more advanced chips, like those found
High-end graphic cards. Inside the graphic cards, also we have microchips, right? The function of graphic cards, the function of microchips on the graphic cards is to use to make the PCs, or excuse me, it's for the PCs, uh, to boost up their performance, right? Also can, so if the graphic cards more expensive, then the microchips use more density and more resistance to any other things, any other problems, right?
on high end graphics cards. There can be upwards of 28 billion transistors on board. More
Masih record nih. Aduh, kayak gitu.
transistors on microchip allow them to send out more instructions of 20 on high-end graphics
Yes, graphic
cards.
cards.
There can be upwards of 28 billion transistors on board. More transistors on microchips allow them to send out more instructions,
Yes,
increasing the
computational
computational
power.
power.
Yes,
Moore's law predicts that computer chip manufacturing would advance at a steady rate, allowing transistor
you
counts
see,
to double
it's the height
every
rate of
two years.
the system
Based
down
on the sheer power of the technology we use on a day
day
to
to day
day
basis.
basis, this decades old prediction
Predictions.
seems to still be mostly true. Manufacturers have been shrinking down their transistor sizes to fit more onto chips. Each breakthrough in transistor size has allowed the production of more powerful chips for our phones, computers, and gaming consoles. In recent years, they've gotten each transistor down to as small as 8 times 10 to the
Yes,
power
two
of
and nine. It's
negative
like this
8
only,
inches in
not big lah.
diameter, allowing an amazing 50 billion transistors to be crammed onto a single
Chip,
chip. Manufacturing
sisters.
microchips is truly one of our most complex feats, and yet innovations are happening every day.
All right, that is feel a little bit about uh, microchip, how microchip makes, and for me, in this video, they explains really good about microchips, and but this video does not wait, that's not explains functions the importance of microchip makes, but it's okay because as all of you can know, as all of you can see, and as all of you knows, microchips are being used in everywhere. Microchips are used at everywhere, at everything, not everywhere. Can be also called everywhere, right? Oh yes, everywhere, everything. like like what I'm saying just now, what I've said moments ago, used on the headphones, on the smartphones, on the laptops, the PCs, on the monitors, also used inside the cars, also inside the ships, inside the battleships, inside the aeroplanes, for the radiator. It also contains the microchip. So basically, uh, the microchips are really important to us, right? Uh, Without microchips, our electronic things can't be used, can't be functional well, and from years to years and from decades to decades, all of you can see that microchips are become more important, more and more important in our daily use and our daily life. And yes, that is a few things about how microchip made. And yes, if you want to watch any other videos from the interesting engineerings in this channel, you can watch it by, so you can see the videos. Videos they have categorized and tool screwdrivers and a lot of more, about electronics or about engineering that all of you can watch from this channel, and I'm really recommended to all of you to watch videos from this channel about engineering, and they will have about 2000 2.3Ks, 2 or 2.3 thousands videos that have been posted until this day, and the last post was 6 hours ago. It was really great for them, and that's all from me. And I'm gonna say goodbye. And yes, don't forget to like, comment, subscribe to my channel. Thank you.